Hello everyone, I'm Satya Sahithi, roll number 2101 CS16, and as part of Big Data Security, I'm going to explain Lab 1 assignment where we have to do the AES 256 encryption, and as part of that, I'm taking the block size to be 128 bits, key size to be 256 bits, and an input text file which usually contains some content, and that is called plain text. And afterwards I'm using a key generation function which basically produces the same key which is used by encryption and also decryption, because AES 256 is basically symmetric encryption algorithm. So in encryption, what we do is we take the plain text and the key, and we encrypt the plain text using the key, and the encrypted version of the plain text becomes to be known as ciphertext. And during decryption, we take the ciphertext and the key, and we decrypt it using the same key generated, and we get the plain text back again. So as we can see, this is the input.txt, and once this plain text is encrypted, we get the encrypted form of the plain text called ciphertext, and we can't really read it. And afterwards, when it is decrypted using the same key, we can see the original content called plain text. And afterwards, we are measuring the performance for various metrics, and as you can see, we are measuring the performance for time, for memory usage, and for CPU usage against input size, which is usually taken in bytes. And we can see the encryption time and decryption time both increases as input size is also increases. So, and we can see the memory usage is also increases as input size increases, and the same goes with CPU usage. And this is lab 1. Coming to lab 2, we have to perform RSA encryption system, which is basically asymmetric encryption algorithm, where we have a function which will generate a pair of keys. One is public key and the another key is private key. Public key is known to all, but the private key is only known to ourselves, I mean the receiver. So here we are generating the keys, public key and private key, and we have a small message called assignment where we are using that to encrypt it and decrypt it back again. So here we can see we are performing the encryption function using the message and the public key of the receiver. So once that is done, we get the ciphertext, and during decryption we use the ciphertext and the private key of the receiver to get the plain text back again. So here is the encryption and decryption, and it follows the asymmetric encryption algorithm. And as you can see, we are also performing the performance measurement, and we can see there are various metrics plotted against input size, and the input is message here, and which is usually taken in bytes. And we can see the metrics in all the graphs. We can see all of the metrics increases as message size increases. So this is lab 2. So this is lab 3, where we have to write a Python program that checks a list of passwords using the criteria. All passwords should be at a length of minimum 8, else it is always invalid. And we have to ask the user for the criteria he wants to check against. So there are 4 criteria. First criteria is the password should be having uppercase letter. Second criteria is the password should be having lowercase letter. Third criteria is the password should be having numbers, at least one number works. And the fourth criteria is the password should be having only some set of special characters like exclamation, hash, and at the rate. So only 3 characters are allowed. So here the user has to select the criterias he has to check his password against. So here the password the criterias are numbered by 1, 2, 3, 4, and he can give the input like 1, 2, 3, 4. so a comma should be separating between the criteria, and he can validate his password later. So we can see this is the validation password thing, where we are defining the criteria. And for the missing criteria, that is if the user chooses more than the number greater than 4, then it is the criteria which is not defined, so basically that is missing criteria. And if you see handle password validation, the user will be giving the password, and we check the password provided by the user against the criteria which user wants to check against. So here we can see, like, we try the set of passwords to check if they are valid or not. So firstly we'll run the code, and we enter the password. The first password is abc 12345, and we check for every criteria, so that's why it is 1 2 3 4, and we validate it. So what we are getting is it misses criteria number 1 and 4. That means the special characters are missing and the uppercase letters are missing. And we check another password, second password, that is abc, and we try to validate it against 4 criteria. And as we can see, abc is checked against all the criteria, and as you can see, the password is invalid, it has less than 8 characters. And also we check the third password that contains all numbers 1 2 3 4 5 6 7 8 9. It contains only numbers, and it is checked against all the 4 criteria. So as we can see, it misses the criteria 1 to 4. It does not have the uppercase letters, lowercase letters, and special characters. And we check the fourth password, that is a b c d e f g and dollar. So we check this against all the criteria, and as we can see, the password is invalid because it misses criteria like uppercase letters, and it misses numbers also. So, and we check the fifth password, that is a b c d e f g a b h d exclamation @313. We check this against all the criteria, and we can see this is a valid password because it contains every criteria. And we try to check the last password, where we are introducing a $$ here, and we check this against every criteria, and we can see it misses the criteria number 4, and it is invalid password because it includes dollar symbols, which is not actually allowed. So we again try to check a b c d e f g and $. And as we can see, it misses criteria numbers 1 3 4, as we have discussed, because it does not include uppercase letters, and it does not include numbers, and it does not include a special character because $ is not a special character. So this is lab 3. So this is lab 4. where we have to implement secure password storage system using SHA-256 hashing, where user should be able to register with a username and password which is stored as a hash. And we also have to implement a login system where input passwords are hashed and compared with stored hashes for authentication. So we are using salting to prevent brute force attacks. So here we know I'm taking a JSON file to store all the login information we get using during register. And also these load user data and save user data is nothing but to store the login information in the JSON file. And you can see the JSON file is this one, and the hash password is where we hash the salt plus password using SHA-256 hash. And this is the register function where the user can register in using his username and password. So one thing here is we check if the username given as an input by the user already exists in the JSON file or not. If it does not, then it's good to, if it exists, then we throw username already exists. So afterwards we generate a random salt and we append this salt plus password and hash it using SHA-256. And afterwards we get the hashed password hash, and we already have the salt, and we save this login information like username, salt and password hash in the JSON file, and we throw user registered successfully. And during login, what we do is we authenticate a user by verifying hashed password. So user during login gives out his username and password. So if the user, we will check if the username is present in the JSON file or not. If it is not present, then he must not have registered, or it might be invalid username or password. So we throw that error. And what we do is we fetch the salt corresponding to the username from login information JSON file. And since we have the salt, we get the password hash using the password given by the user and the salt we fetched from the JSON file. So we have the password hash, and we try to match if this particular password hash computed is matching with the password hash that we stored in the JSON file corresponding to this username. If they match, then the login is successful. If they don't, then we try to throw invalid username or password. So we give user two options, one is register and the second one is login. So since I am a new user, I am going with register, that is choice 1, and here we'll have to register. So I am choosing the option 1 that since I'm a new user, so I want to register first. So it is asking the username, so I would like to enter Satya Sahithi, and it is asking the password. So I'm gonna give 1 2 3 4 5 6 7 8 9 0, and the user got registered successfully because I'm a new user and the JSON file wouldn't have had my name before. So I would like to log in because I registered before, so I will log in this time. So it is asking me the username. So for example, if I enter a wrong username which didn't register before and some random password, then it would say invalid username or password. Or if I enter a right username, so I would like to log in again, and this time if I use the right username and wrong password, that is 1 2 3 4, then it would say invalid username or password because our password is wrong. And this time I would like to give everything correct. 1 2 3 4 5 6 7 8 9 0 is the password. password, then it would say login successful because we have given everything correct. So this is lab 4. So this is lab 5. We are going to perform user authentication and access control. So here we have to implement a role based authentication system where users are assigned roles like admin, editor, viewer. Each role should have specific access rights to files or data. So we must ensure secure user authentication using password hashing and session management. Implementing this as a web-based portal, so users will register on the portal and the admin assigns them admin, editor, viewer rights. So assume that there is no common database wherein the fields are roll number, age, name, branch and hometown. So here I'm using the MongoDB database. So if the user is trying to do an operation which he is not allowed to do it, it should pop an error. So like a viewer should not be allowed to run SQL queries. So here is the code part, and I have already started running, and this is running, the server is running on the localhost 5500. So you can see this is the HTML page. So here I would like to register myself as Satya Sahithi, and email is satyasahithi03, some Gmail, and password I would like to give is 12345, and hometown is TS, and I registered it. Okay, that already exists. So maybe I can try to register as this Satya, and I would like to give this email and I will register. So this is registered. So I will log in using the same credentials, that is Satya 1234 12345. So login. So login is successful, and it redirects to a member list page where we can see the new column, new row here. This is Satya, and the role assigned to her is viewer because she's new to the thing. Since everybody who are new is allocated a role which is viewer, so basically he cannot edit or has any capacity to edit anyone's roles. So he's simply a viewer. He can only see the database, he can only read the contents of the database, but he has no capacity or no rights to edit it. So it is only admin who has the capability to edit the role of the viewer or editor. Even editor has the capability to change the role of the viewer. So anyone who has higher role can change the role of the lower role. So since Satya has viewer, and we will log in using admin. So admin has a hard-coded password 1234. Only admin knows it, and he will use that password to log in to access the database. So I'm logging in using admin credentials just to show what happens and how we can really change the role of a user. So since Satya has viewer and admin can really edit the role, he can change Satya's role into editor. So now you can see the role is updated to editor. So this is lab 5, and lab 6 is we'll have to implement an access control mechanism for a distributed system using JSON web tokens, and users should be able to authenticate, receive a JWT and use it to access secured endpoints, ensure token expiration, validation and role based restrictions. So every user has a role, and every role is associated with a token when he logins. So for example, if I'm using Satya and the password is 12345, so if I inspect it and go to the application part, we can see the role is admin only because we didn't log in yet. So firstly I'll log in. So since this Satya logged in recently, we can see the role to be editor and token to be some value which is stored in the local storage in the application part when we inspect the page. So what happens here is when the user logged in to access the database, he is associated with a token. So when he is performing any operation, like that particular token generated is matched against this the user's token based on his role. If that matches, then it is good to go, else the user is not permitted to do his operations. So this is lab 6. Thank you.